let's see the domain 2. Okay, as we know, domain 1 is nothing but networking basics, which is nothing but and the domain 2 is, as we know, defensive security basics. So so we are exploring defensive security basics, okay, since from the I think day 6 of this particular course. So this is going to be the agenda for this day 13 of our course, Cybersecurity Foundation Basics. So in the first, okay, starting from this particular day, okay, we'll be talking about, okay, very firstly, how redundancy can increase availability, then fault tolerance versus redundancy, then we'll be talking about power redundancy, disk redundancy, network redundancy, and finally, okay, we'll talk about backups and its types. Okay, so let's go and explore these terms one by one. So guys, let's see how redundancy can increase availability. Like if we talk about redundancy, so we can simply say that redundancy is, you know, basically redundancy, it is nothing but the, existence of something that is not strictly necessary, but is present as a backup or fail safe in case the primary system fails or malfunctions, right? So like if we talk about like in the context of communication or information system, we can refer redundancy, okay, as the the use of multiple copies, right, or version of data, okay, or any kind of signals or components to increase reliability and minimize the risk of data loss or system failure, right? Like for example, in our computer system, redundant power supplies or hard drives can be used to ensure that the system continues to function even if one component fails as well. Yeah, like if we take in the context of employment, so this is a very popular one, so we can say redundancy here refers to the situation where an employer no longer needs a particular employee's job to be done, right, often due to changes in the business or economic conditions. Like in this case, the employer may terminate the employee's contract and provide them with a redundancy payment or other benefits. Okay, overall, we can say that redundancy is often used as a way to reduce the risk of failure or loss in various contexts, whether it be in communication system, in employment, or any other areas as well. Okay, recently, if you see, like a lot of companies, lot of tech giants are, they are, just the mass laydown. Okay, like they are just firing the employees, okay, and not like 100, okay, few hundred, they are firing the employees like in thousands, right? So that is nothing but the redundancy of employee. Okay, now what about availability, guys? In CI tried, okay, the availability is one of the factor, okay, and we already understood, we already, okay, learned that particular part. Okay, in the simple words, we can say that availability, okay, basically it's the, it's refer to the degree to which a system, any kind of service or any kind of resource is operational as well as accessible when needed by authorized user, right? It is a measure of how reliably and consistently a system or service is able to provide its intended function to users. in the context of information technology, availability is often measured as a percentage of uptime over a given period of time, right? For example, if a any system, let's say suppose a system that is available 99% of the time, okay, would have 3.6, 3.65 days of downtime per year. Okay, if I say if particular system, okay, 99% available, okay, over the period of a year, so I can simply say, so the downtime of the system will be around 3.65, right? 3.65 days. Okay, so here availability can be impacted by a variety of factors, including hardware failures, software bugs, network outages, okay, cyber attacks, as well as sometimes human errors as well, right? So you will find that, okay, like the few apps that you are using, okay, they are saying that like in the in the night they will be doing the maintenance. Okay, so at that time, okay, at that time of maintenance, okay, the service for that particular app or software is not available for everyone. So as we know nowadays, okay, ensuring high availability is very much important for many critical systems and services. And what are those services? Like financial transactions, okay? Like we don't know like someone, okay, in what time, okay, at what time that person needs some, some finance, okay, need some money. So at that time, okay, financial services would be very much important in that case. So financial transactions, okay, in that case availability is very much important, like in healthcare systems, right, in emergency services, ambulance and all, okay, as well as online commerce as well. So if a a lack of availability can basically lead to lost revenue, okay, or decreased productivity, as well as damage to the reputation as well, okay, and in some cases serious safety risks as well. Okay, so therefore we can say many organizations place a strong emphasis on ensuring high availability and implementing redundancy and failover mechanisms to minimize downtime and maximize reliability, right? Okay, so we can say that availability basically refer to this thing. Okay, now how redundancy can increase availability? We can say that redundancy, okay, can increase availability by providing backup or duplicate components, or we can say systems or processes that can take over in the event of a failure or malfunction in the prime component or a system, right? Like by having redundant systems in place, okay, we can say the overall system can continue to function even if one or more component fails. Okay, so this can help to ensure that the system remains available and operational, as well as that is reducing the risk of downtime and improving reliability, right? So basically, the use of redundancy can also enable maintenance or repair to be carried out on the primary system without disrupting operations, right? So as the backup system, okay, can take over during this time, okay, yes or no? So overall, we can say redundancy can help to increase the availability and uptime of critical systems, okay, making them more reliable and resilient, right? Like for example, if we like if we're talking about like in the in a computer network, okay, we can say redundancy, okay, can be achieved through the use of multiple servers, right? Okay, in computer network, we can say simply by using multiple servers, we can be able to achieve redundancy. Okay, like each of which can handle requests from users. Okay, and if one server fails, the other servers can continue to handle requests. Okay, ensuring that the network remains available to users. Okay, similarly, in a power grid, redundant power sources can be used to ensure that power continues to flow even if one source fails. Yes or no? Yeah. So we also say that redundancy can also be used in data storage systems, okay, where multiple copies of data are stored on different devices, or you can simply say locations, right? Okay. So if I say like one device or one location fails, so the data can still be accessed from other devices or other locations, right? And that is ensuring the data remains available 24/7. Okay. So overall, we can say redundancy provides a way to mitigate the risk of downtime or any kind of failure and ensure that system or services remain available for each and every user, right? Now, let us talk about the different use cases of this. Okay. What are the different domains? Okay. What are the different cases we have? Okay. That we are using this thing. Okay, and then we can say that the redundancy, okay, like how redundancy can basically increase availability. So what are the different applications are these? Okay, so what are the different, where we use this redundancy, guys? Okay, what are the different applications, use cases are this? Okay, so like, okay, let me tell you this, the multiple use cases of this. There are so many use cases, okay, of this, because if someone who who started the startup, or who started the company, okay, so like it's, there is must to, available that particular service or software provided by the company, okay, is should be available 24/7, right? So this is very much important, okay, for each and every cases, each and every field, I would say. Okay, like very importantly, okay, I can say that, okay, the data centers, okay, data center like Google data center, then HDFC data center, and like for each and every organization there is data center, okay, to store their data as well as to, process their data and protect that data from any kind of threat, right? All people, Amazon data center, okay, like one in India, okay, like there are a lot of data centers are there, okay, and near to my home as well, okay, there is one data center which is HDFC's data center. HDFC is the bank in India, okay. So like in, in data center, we can say that redundancy is very critical, okay, to ensure that servers and other critical infrastructure remain operational in the event of a power outage or other failure, right? So redundant power supplies, backup generators, and cooling systems can all be used to increase availability and ensure that critical systems remain online, right? Then what about next? Okay, next and very important use case, I would say, in airline safety systems. Okay, like you will see that, okay, in each and every plane, okay, you will find that there is at least two engines. Okay, you will find that there will be at least two engines, okay, in each and every plane. Okay, why? because okay, when okay, that plane is on the air, so at that time, okay, if something bad happen, let's say one engine automatically stop working, so at that time the second engine, okay, is working. Okay, so it's kind of alternate kind of thing. We can simply say that in aviation, redundant systems are used extensively to increase safety and availability. Okay, like for example, commercial airplanes have multiple engines, like I said before, hydraulics systems, and flight controls, to ensure that the plane can still fly and land safely even if one system fails as well. Yeah. Then what about next? Communication networks. Okay, nowadays communication networks, okay, like will become a most important thing, because for like this networks provide us a the the communication. We can be able to do the communication between, okay, our team members, our families, okay, those are away from us. Okay, as well as, okay, like in big organization as well, okay, communication is also important, like for their safety as well. Okay, communication is very much important. So communication networks such as the internet rely heavily on redundancy, okay, basically to ensure that the data is transmitted reliably and without interruption, isn't it? Like for example, internet service providers use redundant fiber optic cables and routers to ensure that data, you know, can still flow even if one component fails, right? So redundant data centers can also be used to ensure that services remain available even in the event of a disaster or other outage as well. Yeah. So guys, as we know, these are the few examples, okay, that we are that we know, okay, and that we are like airline, okay, like we are traveling by using that, okay, like communication we are using internet, okay, like like all of us, okay, are now using the internet. Okay, so these are the we can say that the these are the daily requirements. Okay, so what are the different use cases are there for redundancy in defensive security? Like as we know, we are talking about defensive security. So what are the different use cases of redundancy in defensive security? So we can say that, okay, redundant firewalls is one of the use case of redundancy in defensive security, right? So basically, in network security, firewalls are used to prevent unauthorized access to a network, right? So by deploying multiple firewalls in a redundant configuration, it is possible to ensure that if one firewall fails, okay, in some conditions, if one firewall fails, so the other can take over and maintain network security without interruption. Okay, so this can help to ensure that the network remains secure and available even if one of the firewall fails. Okay, by just applying multiple firewalls, we can reduce the risk of getting data breach or the any kind of threat or cyber attack, right? What about next? Redundant power supplies. Okay, like in physical security, access control systems and other security equipment often require a reliable power source to function properly. Okay, like by using redundant power supply, it is possible to ensure that the security equipment remains operational even if one power supply fails. Okay, so basically this can help to maintain the security of a facility and to prevent unauthorized access even during a power outage or any other disruption, right? What about next? Redundant data backups. So in data security, data backups are, essential to protect against data loss due to hardware failure, any kind of, human error or any kind of cyber attack, right? So by implementing redundant data backups in multiple locations or using different backup technologies, it is possible to increase the availability and reliability of the backups. So this can help ensure that critical data can be restored quickly in the event of a disaster or cyber attack. Okay, so this is reducing the risk of data loss, right? And ensuring that business operations can continue, okay, or can are available, right? So these are the few examples, okay, that the left hand side you will see that the few examples that you are just need of, and these are the few examples or use cases of redundancy in defensive security. Okay, so let's go ahead and understand the next term, which is nothing but fault tolerance versus redundancy. So guys, fault tolerance, okay, like in a concept, okay, in the computer science and engineering, okay, and that refers to the ability to ability of a system or a component to continue in the presence of faults or any kind of failure as well. Yeah. So fault tolerance gives the system to the ability, okay, to continue operating in the presence of faults or any kind of failures as well. Yeah. Like let's say, okay, a very popular example is your mobile. Okay, let's say if your display of the mobile damaged from one side, yeah, that happen with your mobile and your mobile's display, okay, broke from somewhere, okay, not all 100% broke from somewhere. So at that time you will be able to handle that particular mobile, okay, because your display just broke from somewhere, like a left hand side, upper left, lower left, like that. Okay, so then also you will be able to handle your mobile, you will be able to you know you know do you will be able to run the apps, few apps as well. You can be able to make a phone calls by using that same mobile. Okay, so that is nothing but fault tolerance. Okay, it gives the system or components to the ability of operating in the presence of faults and failures as well, right? So we can say a fault tolerant system is designed to detect and recover from fault automatically without interrupting the normal operations of a system. Okay, like that is like I guess one patent, okay, registered by the Apple. Okay, and because they are working on one technology which is uh, kind of self you know if some device, okay, just destroy from because of some reason, so that device automatically uh, able to again uh, work or able to again attach, like that. So like we can say in fault tolerant system, right? Okay, so we can say in fault tolerant systems, okay, redundancy is often used to ensure that, okay, critical components, okay, have backup systems in place, okay, in case of any kind of failure as well. Okay, so we can simply say this, okay? Like for example, a redundant power supply can be used to ensure that a system continues to operate even if one power supply fails, right? So redundant hard drives or data centers can be used to ensure that data is not lost even if one hard drive or data center goes down, right? Then we can say fault tolerance can be achieved through a variety of techniques, including redundancy error detection and correction and graceful uh, degradation. So redundancy involves duplicating components or systems to provide a backup in case of failure, right? So error detection and correction involves checking for errors and correcting them automatically. Okay, graceful degradation involves reducing the functionality of a system in a controlled manner in case of failure to minimize the impact on users. So overall, we can say that fault tolerance is an important concept in ensuring the reliability and availability of critical systems, right? And the components as well. So by designing systems to be fault tolerant, it is possible to minimize the risk of downtime, data loss, and other negative consequences of system failures, right? Now, after understanding this term, let's go ahead and understand what are the key differences are there between fault tolerance and redundancy. Okay, what are the key differences are there? So, as we understood, what is fault tolerance and redundancy? Like as we know, redundancy is nothing but the backup or any kind of copies of your data, your files. Okay, and what about fault tolerance? So it's self-repairing, and or it gives the system the capability to to work on, okay, work when the system is is having some faults or any issues or any failure. If we're talking about the key differences between fault tolerance and redundancy, so we can say, okay, first different is nothing but their approaches. Okay, their approaches. So we can say that, okay, like fault tolerance is an the approach of fault tolerance, okay, basically that focuses on designing systems to continue operating in the presence of faults and any kind of failures, right? And fault tolerant systems are designed to detect and recover from faults automatically without interrupting normal operations of the system. Okay, what about redundancy? Okay, what the approach of the redundancy, okay, that involves, okay, basically we can say involves, okay, the approach involves creating duplicate components or systems that can take over if the primary component or system fails. Okay, so first first difference is nothing but their approaches. Okay, their approaches are totally different. Then what about next? Their purpose. Okay, their purpose. So if we're talking about the purpose of fault tolerance, okay, basically is to minimize the impact of failure on systems availability and reliability, right? And ensure that the system continues to function as intended even in the presence of faults, right? And what about the purpose of redundancy? So the purpose of redundancy is to provide a backup, or you can say that the in case of in case of failure, right, which can helps to ensure that the overall system remains available and operational, right? Then what will be the next difference? It's implementation. Okay, implementation of these both, okay, are different. Like fault tolerance can be achieved through techniques such as redundancy, error detection and correction, and grateful, degradation, you know. Then redundancy, we can say on the other hand, is achieved by creating duplicate components or simply the duplicate systems that can take over if the primary component or that alternate system fails, right? So we can say redundancy is typically implemented by deploying multiple components or systems in parallel and configuring them to work together to provide a seamless, failover in case of failure. Okay. Now, what about next? Next difference is nothing but the scope. Okay. So as we know, fault tolerance typically applies to a system as a whole, whereas redundancy can be applied at different levels of the system. For example, redundancy can be implemented at the hardware level, like for example, using redundant power supplies or disk drives, right? At the software level, like using redundant applications or services, or even at the network level as well, like using redundant network connections or routers, multiple routers, right? Then what next? Next is nothing but the cost. Okay, so we can say that fault tolerance, okay, can be expensive to implement, right? As it often requires specialized hardware and software that can detect and recover from faults automatically. Okay, so like, okay, if we are using fault tolerance systems, so basically, okay, those systems are expensive than redundancy system, because they have the capability to repair automatically, right? But if we are using a redundancy, or redundant systems, or so we can say this can be less expensive to implement. Okay, as it often involves deploying duplicate components or systems that are less specialized and easier to procure, right? Then what will be the next difference is going to be the resilience. Okay, so if we're talking about, okay, a fault tolerance, so fault tolerance is generally more resilient to faults than redundancy. Okay, like as it is designed to detect and recover from faults automatically without interrupting the normal operations of the system. Okay, and on the other hand, redundancy can be less resilient, okay, resilient, we can say, to faults, as it relies on a failover mechanisms that may introduce some downtime or perform degradation when a failure occurs, right? So in summary, we can say overall, we can say fault tolerance and redundancy are different approaches to improving system reliability and availability, right? And each has its own advantages and disadvantages. Okay, then fault tolerance provides automatic fault detection and recovery from that particular fault, but it can be expensive to implement, right? And on the other hand, we can say redundancy provides backup components or systems that can take over if the primary component or system fails. But redundancy can introduce downtime or performance degradation when a failure occurs. So the choice of approach, okay, so we can say the choice of approach depends on the specific requirements of the system and the resources available to implement, right? Okay, like let me tell you one incident. Okay, how many of you know about Apollo 11 moon landing? Apollo 11 mission is very famous mission, okay, conducted by NASA, right? And basically, okay, like as we know, in making the satellites, okay, like there are some constraints, right? Like, okay, let's say there are some constraints of, weightage, okay, weights of the satellite is one of the constraint, right? So instead of using redundancy, okay, instead of using multiple systems, okay, we have to use fault redundancy, right? So, okay, if we're talking about this particular mission, okay, so during, okay, the Apollo 11 mission, okay, and that mission conducted in 1969, okay, we can say the, the guidance of, the guidance computer on the lunar module surfaced, you know we can say, so basically that the guidance computer, on the lunar module suffered a, series of error that could have, jeopardized, jeopardize the mission. Okay, so like however we can say the computer was designed with fault tolerant features that allowed it to, detect and the correct the errors automatically, and ensuring that the mission was completed successfully. Okay, so that is a, importance of fault redundancy, right? What about next? Toyota Prius, braking system. So if we're talking about this, so like in 2010, Toyota announced a recall of its Prius hybrid vehicles due to a potential fault in the braking system. So the fault was caused by a software error that could cause the brakes to fail under certain conditions. So, however, the Prius was designed with a fault-tolerant system that allowed the driver to manually override the brake system and bring the vehicle to a stop in case of failure. Okay, so again, they used a fault redundancy system, okay, in the braking system to stop the car, okay, in the case of any failure or in the case of any, accident. So what about next? Space shuttle change, Challenger disaster, right? So if we're talking about this particular, you know, news, so we can say like in 1986, the space shuttle Challenger exploded shortly after liftoff, killing all 7 crew members on board. And this disaster was, caused by a failure of the o-ring seals. Okay, like no one, like o-ring seals, on one of the, solid rocket boosters, we can say, which allowed it hot gases to escape and damage shuttle's fuel tank, right? One of the contributing factors to the disaster was a lack of fault tolerant design in the o-ring system, which made it vulnerable to failures under certain conditions. Okay, so we can say these incidents, okay, which demonstrates the importance of fault tolerance in critical systems such as space vehicles, in automobiles as well, and in computer systems as well. So by designing system with fault tolerant features that can detect and correct errors automatically or provide backup options in case of failures, so it is possible to improve the reliability and safety of these systems. Okay, so basically, you know, the the 3 Mile Island, we can say that 3 Mile Island uh, nuclear power plant in Pennsylvania, okay, experienced a partial meltdown of one of its reactors. Okay, so however, the safety systems and the redundancies, okay, built into the plant's design prevented a catastrophic release of radioactive material, and there were no fatalities or injuries as happened as a result of the incident. Okay, then like you know uh, in around, I would say, in 2009, okay, US Airways flight 1549, okay. So basically, if you're talking about this, US Airways flight 1549. So in 2009, US Airways flight, okay, 1549 suffered a bird strike. Okay, basically, okay, bird, okay, bird hits to that particular plane. Okay, so bird strike that basically caused both engines to fail shortly after takeoff, and the pilot was able to safely land the aircraft in the Hudson River. In the river he landed the aircraft, and all passengers and crew were evacuated without serious injuries. So uh, we can say that the one of the factor that contributed to the successful outcome of incident was the redundancy of critical systems, okay, such as the multiple backup power sources and hydraulic systems that allowed the pilot to maintain control of the aircraft despite the engine failure, right? So what about next incident, which is going to be the northeast blackout of 2003. Okay, like in 2003, a power outage affected much of the northeastern United States and parts of Canada as well. Like, and then people started living, okay, without electricity for several days as a, okay. So the outage was caused by a series of failures in the power grid, but the impact of the outage was limited thanks to the redundancy built into the grid's design. Like for example, some critical infrastructure such as hospitals and emergency services had backup power sources that allowed them to continue operating during outage as well. Yeah. So overall, we can say that these incidents demonstrate the importance of redundancy, as well as as we explain this fault tolerance. Okay, so in critical system we can say such as nuclear power plants, aircrafts, and power grids. So by implementing redundant systems and backup options, it is possible to minimize the impact of failures and disasters on the safety and availability this of these particular systems, right? So now let's see the different types of redundancy. So first one, is going to be power redundancy. Okay, power redundancy. In case of power off or some kind of power failure or power outage, we can say, okay, at that time we need the redundancy system, and those systems are nothing but the power redundancy, we can simply say. So we can say, okay, this power redundancy basically refers to the use of backup power resources, right, or redundant power systems to ensure continuous operation of critical infrastructure even in the event of a power outage or failure, right? So this particularly important for systems that require constant uptime, such as data centers, hospitals, and manufacturing facilities, right? Now, let us understand what are the, what are there, different kinds of ways, okay, to implement power redundancy, okay? Like as we know, backup generators are there, right? Backup generators are there. So these backup generators can provide power in the event of a power outage or failure, right? So these generators are often powered by diesel, like you mentioned, diesel, diesel backup generator, I would say, okay, as well as natural gas, or any different kinds of the liquids like propane, okay, and can provide power of extended periods of time, UPS as well, yeah, solar power, right? Then what about next? Uninterruptible power supply, we can say UPS systems, okay. So we can simply say a UPS system uses batteries or flywheels to provide backup power in the event of a again power outage, or any kind of voltage fluctuations. So UPS systems are typically used for short-term backup power, right, allowing for critical system to be safely shut down or for generators to kick in, right? Then what about next? Redundant power sources. So like for some critical infrastructure, okay, may have redundant power sources, okay, like such as multiple power feeds from different utility companies, okay, or multiple transformers or substations as well, right? So this ensures that even if one power source fails, the other source can continue to provide power, right? Then what about next, which is dual coded IT equipment? We also say that the DC, right? So in IT environments, DC equipment can be used to provide power redundancy, right? So this means that each piece of equipment is connected to, two separate power sources, and which is allowing it to continue operating in the event of a, power outage or failure, right? Then what about next, which is going to be redundant power supplies, right? So like some servers and networking equipment have redundant power supplies, okay, which allow for continued operation in the event of a single power supply failure, right? So what are the real life examples are there? Okay, what are the real life examples are there? So as we know, what are the different sectors are there? Like hospitals, okay, in hospitals, okay, there will be a need of uninterrupted power supply, okay, to operate critical equipment such as, ventilator and all, right? Then what about next for airports, right? Like airports use power redundancy to ensure that critical systems such as runway lights, air traffic control systems, and security systems are always operational. Okay, they may have backup generators, battery backups, or multiple power feeds to ensure continuous power supply. Then in banks, right? So bank rely on continuous power supply to operate their electronic banking system, ATMs, and other critical systems, right? And they often have backup generators or battery backup to ensure that power is available at all times, right? Then what about next? Manufacturing plants. Okay, they also need a uninterrupted power supply. Okay, because okay, you will find that okay, in manufacturing plants you will find that the robots, different belts, okay, those are constantly running, okay, and other machineries, okay, that require uninterrupted power supply, okay, to operate efficiently. So they may use backup generators or battery backups to ensure that power is always available. Then what about next in telecommunication sector as well? You will find that okay, it's a basically okay, you will find that critical equipments, okay, such as the cell towers, switches, and routers, okay, those require continuous power supply to operate, right? And that's why okay, you will find that the power redundancy they will use, right? Data centers as well, guys. We'll talk about that in the defensive security part. Okay, like now what are the different real life examples are there in defensive security, those who are okay, those who need power supplies? Like first one is data center. Okay, what about next? Basically SOCs require uninterrupted power supply to operate their security systems such as security cameras, access control systems, and security appliances, right? Yeah, yes, NOCs as well. So they often use backup generators or battery backups to ensure that power is always available even during power outage or disruptions as well. Okay, then next is nothing but data centers. Like we all know, like in data centers, okay, doing each and everything, okay, we will require okay, power. So like to for their servers, for their network devices, okay. So that's why data centers also require uninterrupted power supply for their security systems such as security cameras, right? Their access control system and security appliances. Okay, so they often use backup generators or battery backups to ensure that power is available, right? Then what about next? Network Operations Center, NOCs. NOC also require uninterrupted power supply to monitor and manage network devices and basically ensure that they are secure, right? So they often use backup generators or battery backups to ensure that power is available each and every time. Then what about next? Military facilities, right? So military facilities require uninterrupted power supply to operate their critical systems, okay, right? Like their communication systems, surveillance system, okay. Then uh, like other equipments. Okay, like they often use battery backup generators or battery backups to ensure that power is always available even during power outage or disruption caused by natural disasters or other events, right? Then what about next? Financial institutions. Again, as we know, financial institutions also require uninterrupted power supply to operate their electronic banking systems. Okay, their EDM and other critical systems. Okay, so they often use backup generators or battery backups to ensure that power is always available even during power outage or disruptions caused by cyber attacks or other events, right? So guys, these are the few real life examples you will see that, okay, of the power redundancy. So let us talk about the next redundancy or next type of redundancy, which is nothing but the disk redundancy. As we know, disk redundancy refers to the practice of using redundant disks, okay, or you can simply say that the backup storage options to ensure data availability and prevent data loss in the event of disk failure. Okay, so we can say disk redundancy is important for critical data storage applications such as our databases, email servers, or file servers as well. Okay, so as we know, what are the different ways are ways to implement disk redundancy? So what are the different ways are there? RAID is there, redundant array of independent disks, right? So yeah, so let me explain what is RAID. So we can simply say that RAID is nothing but a technology that combines multiple hard drives into a single unit. Okay, we can say that into a single logical unit, and data is distributed across the drives, okay, in a way that, okay, that data provides redundancy and allows for continuous continue operations in the event of a single drive failure, right? Yeah, so we can simply say that, okay, this mirroring is also known as RAID 1, right? And basically mirroring involves duplicating data across two separate disks. Okay, so in the event of disk failure, okay, if any one disk failure, the mirror disk can be used to restore that particular data, right? Then what about next? Backup and recovery. Okay, so in addition to disk redundancy, it is also important to have regular backups of critical data. Backups can be stored on redundant disk system, storage, cloud storage, we can say, or offsite locations to ensure that data can be recovered in the event of, catastrophic failure, right? Then what about next? Parity. We can simply say this is a type of RAID that uses a dedicated disk to store parity information. Okay, so this information can be used to reconstruct data in the event of a disk failure. Yeah, then what about next? Network attached storage, NAS. So we can simply say NAS is a storage device that connects to a network and provides file level data access to multiple clients. Okay, so NAS devices often include redundant disks and other features to improve reliability, right? Then what about next? Storage area network, SAN. Okay, SAN is a dedicated network that provides block level data access to multiple servers, right? So SANs often include, redundant disks, power supplies, and other features to improve reliability. Okay, And most common one, which is nothing but cloud storage. Yeah, as we know, we all guys are using cloud storage, Google Cloud. Okay, so cloud storage provides offsite storage for data, often with redundancy built in, right? So this can include both public cloud storage solutions like Amazon's S3, isn't it? Microsoft's Azure or Google Cloud, as well as, there are so many private cloud solutions as well, right? So basically implementing disk redundancy is important for maintaining your data availability and preventing your data loss in critical data storage applications. Okay, so by implementing redundant disk systems and backup options, it's possible to minimize the impact of risk failures or disk failures or data availability, and ensure that critical data is protected against disk related security threats such as malware or hardware failure, right? Now what are the different examples are there, okay, of for the disk redundancy? Okay, because it's a technique, okay, that is used in server as well as storage systems and other computing systems. Okay, and basically it uses multiple disks to store data and provides redundancy by by replicating data across multiple disks. Okay, if one disk fails, the data can be rebuilt from redundant copies on the remaining disk, right? Then what about next? As I mentioned, cloud storage. Okay, this is again a real life example, I would say. Okay, so again, basically, this also ensure that customer data is always available even in the event of disk failure, right? What about next? Video surveillance systems. Okay, video surveillance systems. So basically, this often use disk redundancy to ensure that recorded video footage is always available, right? Even in the event of disk failure. Okay, so they use techniques such as RAID to store the data, that particular video data redundancy, so redundantly across multiple disks as well. Okay, what about next? Multimedia production. Okay, so in multimedia production, disk redundancy is used to ensure that large video and audio files are always available for editing and post-production work, right? So here also RAID, okay, will be used, okay, to store that data redundancy. Then what about next? Financial institution. Okay, like for many financial institution, their transaction data is very much important. Okay, so that's why they will have to use disk redundancy, okay, to store critical data such as their confirm customer information, like their transaction logs, like, and other financial data. Okay, and basically they also use RAID, okay, to ensure their data is stored redundantly across multiple disks, right? Then what are the different examples are there in defensive security of red disk redundancy? As we know, the first and most useful one, which is nothing but network attached storage, NAS. Okay, so as we know, NAS devices often use disk redundancy techniques such as RAID, okay, to ensure that again stored data is always available and protected against disk failure, right? Then what about next? SE, SIEM, right? NAS is a NAS devices often use a disk redundancy techniques. These are the network attached storage devices. Okay, these use RAID to ensure their data is safe and secure. Okay, again against any kind of disk failure. So basically these devices, okay, are collecting system logs, right? These devices are connecting system logs and network logs, right? So what about SIEM system, guys? Security information and event management system. Again, as we know, okay, this SIEM systems also require disk redundancy, basically to ensure that logs and other security event data are always available, right? uh, to basically to protect it against any kind of disk failures, right? So again we can say these systems often store large amount of data and rely on redundancy to avoid data loss, right? Then what about next? Intrusion detection system. Okay, basically this detects the intrusion. So for these devices as well, okay, they need disk redundancy to ensure that logs and other critical data are always available and protected against disk failure. Okay, so this is important for maintaining its integrity of security data, right, such as alerts and event logs. Okay, then what about next? Security cameras and video recording systems. Okay, so here also security cameras and video recording systems often use disk redundancy techniques such as RAID to ensure that video footage is always available and protected against disk failure, right? So this is important for maintaining the integrity of recorded security events and for supporting forensic investigations, right? Then lastly, what about access control systems? Okay, so access control systems require again disk redundancy to ensures that system configurations, log data and other critical data are always available and protected against disk failure, right? So again, this is very much important for maintaining the integrity of systems operations and for supporting forensics investigation in the event of security incidents, right? So these are the few examples, guys. You will see that in different sectors as well as in defensive security as well. Okay, for the use of disk redundancy. Now let us talk about the next, network redundancy. Okay, in the name itself there is word network, so which means that this is totally related to network. Okay, and their network data backup, you can say, you know so we can say that, okay, basically this particularly network redundancy refers to the practice of implementing backup or redundant network infrastructure, right? Okay, the backup and redundant network infrastructure, okay, to ensure continuous network connectivity and availability, right, in the event of a failure, or you can say that the outage. So network redundancy can be implemented at various level, including the physical layer, okay, network layer and application layer. So in a in the physical layer, network redundancy can be implemented by having multiple network cables or paths connecting network devices, or you can say that the switches and routers. So this ensures that if one cable or path fails, data traffic can automatically be rerouted through the redundant path. Okay, so redundant power supplies or cooling systems and other hardware components can also be implemented to ensure the availability of the network infrastructure, right? Then what about next? The second layer is going to be a network layer. So in the network layer, okay, the protocols such as the STP, we can say spanning tree protocol, okay, or VRRP. So this VRRP stands for virtual router redundancy protocol, okay. So we can simply say that these protocols, okay, can be used to provide redundant network paths and enable automatic failover in the event of a failure. Yeah. So here STP prevents network loops by disabling redundant network paths, right? While VRRP, this second protocol, provides automatic failover of routers in case of a primary router failure. Yeah. The full form of STP is nothing but spanning tree protocol. Okay, is nothing but spanning tree protocol. Okay, and the VRRP stands for virtual router redundancy protocol. Okay, these are the two different protocols, okay, you can use in network layer. Okay, then in the application layer, load balancing can be used to distribute network traffic across multiple servers or network devices, right, ensuring that no signal is overloaded or become a single point of failure, right? So DNS, okay, data name server, you can say, okay, this load balancing can also be used, DNS load balancing, okay, can also be used basically to, okay, distribute network traffic across multiple servers. So like implementing network redundancy is very much important for maintaining network availability, preventing costly downtime, and ensuring business continuity, right? It also provides a level of security and protections against network related security threats such as cyber attacks, okay, that may target network infrastructure. Okay, now here also, what are the different ways to implement network redundancy? Redundant network connections, okay, redundant network connections, okay. So basically this involves connecting multiple cables or paths between network devices, switches and routers to provide redundancy in case of cable or path failure, right? So this can be done using technologies such as link aggregation, LAG, or port channeling, right? Then what about next? Redundant network devices. Okay. So implementing redundant network devices such as switches and routers. Okay. Basically, this can provide backup functionality in case of a device failure. Okay. So this can be done by using technologies such as the spanning tree protocol, as we discussed before, or the virtual router redundancy protocol, which is nothing but VRRP, right? Then what about next? Load balancing. Okay, as I mentioned one word, load balancing, in the previous network redundancy topic. Okay, so here also you will see that, okay, load balancing is a technique used to distribute network traffic across multiple servers or across multiple devices, right? And that ensuring, that, basically to ensuring that no signal device is overloaded or become a single point of failure. So this can be done using technologies such as round robin DNS or hardware load balancer, right? Then what about next? Redundant power and cooling systems. Okay, so implementing redundant power and cooling systems can ensure that network infrastructure remains operational even in the event of a power or cooling failure, right? Now, what about next? Cloud-based redundancy. Okay, so cloud-based redundancy involves replicating critical network services and applications in the cloud. Okay, providing backup functionality in case of an on-premise failure, right? So the cloud-based redundancy can also provide geographic redundancy, and that is, ensuring that network, services remain available in case of a regional disaster. Okay, then what about next? Disaster recovery planning. So here, okay, you can see in this implementing this particular disaster recovery plan can help to ensure that, the network infrastructure remains operational in case of a catastrophic failure. Okay, and this include having offsite backups, secondary data centers, and alternative network connectivities options, right? So you know by implementing network redundancy, organizations can ensure that their network infrastructure remains operational and available in the event of a failure or outage. Okay, reducing the risk of costly downtime and ensuring business continuity. Right? So, what are the different real life examples are there? Like, as we know, cloud computing is there. Okay, like the cloud computing providers often use network redundancy to ensure that their services are always available, right? Even in the event of a network outage. So they use techniques such as load balancing and failover to ensure that network traffic is automatically rerouted to backup systems in the event of an outage. Then you will find that, okay, network redundancy example is, the in the telecommunications as well. So telecommunications providers use network redundancy to ensure that their services are always available to their customers. Okay, and they often use redundant network connections and multiple data centers to ensure that network traffic can be automatically rerouted in the event of a network outage, right? Then what about next? Bank, in the banking and finance as well. Yeah, these are the real life example, guys. Okay, like we are not talking about the connection, how to build the connection between cloud computing and telecommunication. Okay, these are just the real life examples of, where you can use network redundancy. Okay, where we can implement network redundancy. So these are the few sectors you will see that over there you will definitely find that network redundancy. Okay, and they are using network redundancy because it's the, very important aspects of the businesses. Okay, to available their, their services. Okay, 24/7. So as we know, for banking and finance as well, they also, require a high level of network redundancy, right, to ensure that their services are always available to their customers, and they use redundant network connections and multiple data centers to ensure that network traffic can be automatically rerouted in the event of a network outage, right? Like in medical systems as well, if you know. Okay, in medical systems, okay, such as hospitals and, clinics. Okay, those are, rely on network redundancy to ensure that critical patient information is always available to the medical staffs, right? So they use redundant network connections and backup systems to ensure that patient data can be accessed even in the event of network outage, right? Then what about next? Industrial control systems, right? So as we know, industrial control systems such as power plants and manufacturing facilities, okay, those also, require high level of network redundancy, basically to ensure that critical systems remain operational. Okay, so they also use redundant network connections and backup systems, okay, to ensure that their control systems can be accessed and operated even in the event of network outage, right? Now, what are the different examples are there, okay, from the defensive security, okay, where we use network redundancy in defensive security, guys? Yeah, if we're talking about this term, okay, like we can, okay, use network redundancy in defensive security like multi-home network connections, right? So we can say in multi-home network connections, okay, a device is connected to multiple internet service providers, okay, for redundancy. So this can provide an additional layer of security by ensuring that if one ISP goes down, the network can still operate through the other internet service provider, right? Okay. Then what about next? Dual firewalls. Okay. As we all know, okay, like dual firewalls are often used in network security, right, to provide redundancy. If one firewall fails, the other firewall can take over and keep the network secure, right? Then what about next? Load balancing. So load balancing, we can say, is nothing but a technique used to distribute network traffic across multiple servers or devices. And basically this can help to ensure that no signal device or server is overloaded, right? And okay, that can also provide redundancy in the event that one server or device goes down, right? Then what about next? Network failover. Okay. So as we know, network failover is nothing but a technique that automatically switches to a backup network connection in the event of a network outage, right? So this can provide redundancy and help to ensure that network remains operational even during an outage as well. Okay. And lastly, we have redundant network infrastructure. Okay, so we can say that redundant network infrastructure involves having multiple switches, multiple routers, and any other network devices to provide redundancy, right? So if one device fails and the network can continue to operate through the other devices, right? So this basically helping to ensure that network remains secure and operational. Okay. So means availability is very much important. Okay. And for just applying the availability in our system, okay, we are doing this thing. Okay. So that is why you will find that, okay, CI triad is very much important, and most of the companies, okay, are implementing it. Okay. Now let us talk about the backup and its type. Now guys, what is backup? As we all know, I guess all are using backup, okay, in their smartphone, in their system like laptop, their computer, their desktop, okay, their tablets. Yes, we were talking about the, the network redundancy. Okay, so network failover is going to be a type of network redundancy, right? Because in the last slides we are talking about redundancy. These are the few examples of network redundancy, right? So means here you will find that we are talking about the what are the different cases. Okay, what are the different use cases of redundant network redundancy in defensive security. Okay, then what is backup, guys? As we know, backup is nothing but a copy. Yes, UPS is nothing but the backup. Yeah, in cloud also we can set our backup like a WhatsApp also. Okay, WhatsApp give a backup on its server, right? So we can simply say that backup, okay, is the process. Okay, we can say backup simply refers to the process of copying and archiving data and system configurations to a secondary location, device, or you know a medium for the purpose of data recovery in case of data loss or corruption, right? So we can simply say backups are an essential part of data protection and disaster recovery planning, right? Okay, like these are various type of, okay, like there are a lot of different types of backups are there. Okay, we'll explain those types, like including full backups, okay, incremental backups, okay, like that. So we'll be talking about those after understanding this backup, right? So we can say that, okay, like as we know, we can do the backup like manually as well as automatically. Like if we say if you are working on let's say on a cloud, okay, like if you created a one Excel file on the cloud, okay, so if you are editing that cloud, okay, whenever you want to edit, okay, and that will automatically save on the cloud, right? So that is nothing but that is saving your file. Okay, so we can say that we can do backup automatically as well as manually as well, like WhatsApp automatically, okay, uh, will automatically, okay, is doing the backup, right, of our chats. So using backup software, we can say we can do this automatically, automatic backup, or this thing, okay, or we can simply use built-in backup features in operating systems as well. So backup media can include hard drives, the tapes, and cloud-based storage as well. So backup strategies vary depending on the needs of the organization and the criticality of the data being backed up. Okay, so some organization may require daily backups while others may only need weekly or monthly backups. So it is important to ensure that backups are performed regularly and that backup media is stored securely and offsite, right? So the process of restoring data from backups involves copying the data from the backup media to the original location or to a new location, right? So restoration can be done manually or using backup software as well. Okay, like recycle bin as well. Okay, like if we try to understand this thing in the recycle bin, if you delete some information, that is nothing but automatically stored in the recycle bin for I guess around 30 days, right? And then it will automatically delete if if you didn't restore that particular data, that particular information from the recycle bin. So again you can say that you can put you can say that is if you wanted to do the backup of your deleted data, so you can do the, instead of doing overall delete, you can do the put your data into the recycle bin. Yeah, so if you change your mind, so you can restore that data as well from the recycle bin. So now let us understand what are the different types of backups are there. Okay, what are the different types of backups are there? Okay, quickly, full backup. Now what is, guy? Okay, full backup. Full backup is nothing but we can say that the complete backup of our overall data, right? Then what about next? Incremental backup. So we can say that incremental backup is the backup of only the data that has changed since the last backup, right? Means you are doing backups regularly or daily basis, like, or monthly basis or weekly basis. So at that time, okay, you can use incremental backup instead of full backup, right? So whichever data you just updated in that data, so only that data will be will be stored in the your previous backup, right? Then what about next? Differential backup, right? Absolutely. Okay, so again we can say it is a backup of only the data that has changed since the last full backup. Okay, so that is nothing but a differential backup. Okay, now what about next? Synthetic backup. So we can say synthetic backup is a type of backup that combines a full backup with one or more incremental backups to create a full, new full backup. Okay. So basically this type of backup can reduce, backup time, and storage requirements as well, right? Then what about next? Mirror backup. Okay, so we can simply say that this type of backup, okay, which can simply creates an exact copy of the source data on a separate storage device or server. Okay, basically, okay, that backup, okay, this synthetic backup combines a full backup with one or more incremental backups to create a new full backup, right? So this type of backup can reduce backup time and storage requirements. Okay, like for example of the like of the synthetic backup, okay, a company perform a synthetic backup every week, okay, combining a full backup with the incremental backups from the previous week to create a new full backup. Okay, the difference between full backup and incremental backup is that full backup is a complete backup. Okay, and what about incremental backup? That let's say you are doing the backup, you are on the regular basis, you are doing backup like a weekly basis. So in a first week you did backup. Now in the second week you created some some data. Now, instead of storing your overall data with previous data, you can simply, back up your current data that you generated in that particular week. Okay, and you can store that current week data in the, in the previous backup. So that is nothing but the incremental backup. Got it? Now, what about cloud backup? Okay, what about cloud backup? Cloud backup is, also we are doing the backup on the cloud like Amazon S3, Microsoft Azure, Google Cloud, right? Then we have the local backup. So we can simply say that local backup is nothing but the local storage device. Okay, just we are doing the backup on the local storage device. Okay, like our let's say external hard drive, right? Or network attached storage as well. So this, we can say this type of backup is very useful for quick recovery of data in case of hardware failure. Okay, like if we have other, one more hard drive, so you can simply use that hard drive, okay, to, just for the backup, and in case of any, any uh, hard drive failure, you can use this external hard drive. Okay, now what about next? Remote backup. So we can say remote backup involves backing up data to a remote location, such as secondary data centers or a cloud-based storage services. Okay, like for companies, okay, there is no, one data center. You will always find that there are a lot of data centers. Okay, and you will find that, okay, if one data center destroys, okay, because of some, incidents like earthquake and all, so then the data can be recovered from the other locations data center, right? So that is nothing but remote backup. And what about next one? Continuous data protection, which is nothing but CDP. So we can say CDP is a type of backup, okay, that continuously backs up data as it changes. Okay, as you are changing the data, okay, it is backing up the data, right? So that's the thing. You can also say that the real-time backup as well. Okay, so that's about this particular session, guys.